Welcome to another episode of CCSD Earth Science. Today we're going to be focusing on the formation of metamorphic rocks. And the main formation of metamorphic rocks is through heat and pressure. And that can happen in a variety of ways that we'll talk about. But the big thing with metamorphic rocks is that they're heated enough to recrystallize the minerals that are in that rock, but not enough to actually melt it. So it doesn't become a liquid like what happens in an igneous rock. So there's just enough heat and pressure to change the existing rock that you started with. And there's two different ways that we can form a metamorphic rock. One of the ways is through regional metamorphism, and this is something that happens on a very large scale, such as when continents are colliding, like when Africa and North America collided, that actually created the Appalachian Mountains along the eastern coast of the United States. And as you can see, it creates kind of a folded effect in that landscape. So when you look at even aerial images of the eastern part of the United States, you have this rolling hills appearance, and that's from that collision. So that's changing the way that the landscape looks, and it's also changing the crystal structure and the crystals that you see within that rock as well. Another way that a rock can become metamorphic is through contact metamorphism, and this is on a much smaller scale. We're talking within several feet or even inches that you can see contact metamorphism happen. And this is typically going to happen when you have an igneous intrusion that comes up through existing rock, like you have right here. And so this magma is coming up through, and because it's so hot, it actually will change whatever rock that it is going through. So this is your existing rock that was there. This comes up through, heats it up, and recrystallizes along that border. So where all these little lines are is this zone of contact metamorphism that has occurred. And this can also happen when you have a volcanic eruption and the lava flows that go across the surface of the earth as well can create some contact metamorphism. And so when we look at contact metamorphism, a lot of times we're looking at what was there beforehand in order to create that new metamorphic rock. Now when we look at metamorphic rocks and try to identify them, there are two different textures that we look at. The first one we're going to look at is foliated. And these are when you have bands of minerals that are migrated together because of that heat and pressure. The similar minerals all come together, and we call that mineral alignment. And depending on the amount of metamorphism that occurs, the appearance of the rock will be slightly different. But the main thing that you'll see is an alternating band of light and dark minerals. So if we look at this example right here, this is mineral alignment. You can see light, dark minerals. But this is under low-grade metamorphism, okay? Over here, this would be high-grade metamorphism, much larger scale usually. You just have a lot more forces that are occurring. And you can see it has this banding, we call it, where it's a lot more wavy in appearance. And so I can show you a couple of examples of that. Right here, this would be more considered a, let's see if we can get a good side for you. This would be more considered banding. Okay, you can see that there's the light and dark minerals in there. And then, we even got one more piece. Right here as well, you've got that light dark appearance to the rock. But something like mineral alignment, you're going to see in something like this right here, where you can see that there are similar minerals within. It's kind of blurry, there we go. Similar minerals have come together, but there's not distinct waviness or banding to it, and that's what we would call mineral alignment. One more example here, we'll see how it shows up on the camera. Let that focus. No. Not really showing up too well there, but basically with mineral alignment the coloration isn't going to change as much as what you see with banding, where you've got that distinct light dark, and it's very wavy. Okay, and again that has to do with the amount of metamorphism that occurred to that rock. Now, non-foliated rocks really don't show a lot of features. They're a little bit harder to identify as metamorphic. Marble is a good example of a metamorphic rock. It's definitely been crystallized, recrystallized, but it really doesn't show that foliation, that banding, that intense pressure that that rock has undergone. It's mostly from the heat and the recrystallization of the minerals that creates the new metamorphic rock. And just to kind of show you some examples of with contact metamorphism, a lot of times what you need to be able to understand is where the rock came from. And really with all metamorphic rocks, they started out as something else at one time, underwent the heat and pressure, and transformed into something else. So if we look at this little setup right here, we have an intrusion that was granite. We've got some limestone and sandstone that had existed before the intrusion. When this intrusion came up through, and it made contact with the sandstone. When you add heat and pressure to sandstone, you're going to end up with quartzite, which is a metamorphic rock. So all along that area where there was sandstone, that sandstone was heated and some pressure was added to it, and that created this zone of quartzite. If you look at B is touching some limestone. So when this intrusion came up through the limestone, at that area and really along that whole border, when the limestone underwent heat and pressure, it became marble. So when we look at what the rock was, you can actually figure out what it will become or what it has become based on that. So we can use what we call the parent rock, and that is where the metamorphic rock had originated. So when you add heat and pressure to different kinds of rocks, you're going to end up with a certain kind of metamorphic rock. Your reference table on page 7 goes through and explains a lot of that information, and we're going to be using this a lot during class. And you can see on the left side over here, they show you texture. So you've got foliated and non-foliated. It goes through and explains the mineral alignment versus banding, the grain size, composition, what minerals are in that rock, and how much metamorphism it has undergone. So as you go down the chart from top to halfway, the metamorphism is increasing. So you're going to change the appearance of the rock and what kind of rock you end up with. But under comments is really where you need to look carefully. That's what's telling you what the rock used to be, what it started out as before the heat and pressure was applied to it, and what it has become. And then the rock symbol or the map symbol is over on the far right side. On the bottom half of the map or the diagram is showing you the foliated rocks, and it again is showing you the grain size, the composition, what type of metamorphism, and what it's made of. So this page we're going to be using a lot to figure out what the rock started out as before it became the current metamorphic rock that we have.